That's fine. Okay, so just before I jump in, I got my one advert slide. Since joining Appear, which was actually a year today, it was this very conference day last year, was my first day with Appear. I've been doing these podcasts, aptly called Time for Tea. Somebody did suggest we should call it Something's Brewing. That's an alternative take. But anyway, do check them out. You can subscribe on Spotify or any other one you want. Okay, so I think there's two or three slides you've seen before, but just setting the principle. So first of all, we are now doing distributed production. So the concept that the control, the acquisition, and the storage and processing is co-located is no longer a thing. And a lot of what we do as an organization contributes into that with the various standards we're doing. But the fact that down the bottom there, cloud, be it publicly or privately hosted, is now going to be the storage and processing location of choice, plays into what we're talking about here. And this is again, just that element of the live workflow, the different elements right from the acquisition through the different processing elements right through to the consumption, the workflow of the live production chain that we're talking about. And we're talking about that bit between the acquisition and including the processing. We've also heard, and Felix isn't in the room at the moment, but there he's just walking in. The man that created the word dematerialization has walked in. And he had a better slide than me on this one. But basically, we are moving in terms of that live production workflow components from physical appliances into software solutions. And those software solutions may not even be hosted in my space. They may be absolutely anywhere else. Another thing, why are we at this point of inflection now? It's because compute has come of age. So compute is actually capable of doing what we want. We've got interfaces that are fast enough to do what we want. We've got compute that's powerful enough to do what we want. And the IT industry has provided all of those foundational building blocks we need to run stuff on. I'm not going to unpack this slide, but that's the reason we're actually able to make the transition that we're talking about now, or the evolution. Okay, so this is a slide I think I first put up a couple of years ago, but I think it's incredibly important, and this really is the play of what we're talking about here, because we have had a heritage of linear connectivity for 92 years, probably, something like that, where everything is like a hose pipe. You push it through, be that an analog connection, be that an SDI pipe, be that 2022-6, 2110. Everything is like that hose pipe of based. And that's why we've got away with very sloppy recommendations on how we do timing and time propagation, because if you're in a hose pipe and the next bit's always coming behind you, then you don't need to be so careful about the way you time. But actually, that's much more a thing when we become asynchronous or non-linear in the way we're handling the data. And software can be, as John said, can take its time to do things, but typically in software, it actually does things much quicker. It just does bulk stuff. It does stuff. It's ready for the next time. And therefore, we can use compute much more efficiently. And what we're talking about here is compute native stuff, actually using compute, and everything from the discussions we were having on P groups earlier, everything about why 2110-21 isn't very good for compute is all because it's not how compute works best. And what we're trying to do in this demarcation point in the industry at the moment is actually say, let's now define some stuff that works for native compute. And I think I referred to this just now, but this transition to non-linear, so 92 years of linear analog, digital, and linear IP, with all of those different standards, the way we've done stuff, and we're now at this transition point with the opportunity to create something that's open for the industry. And I think you've got the gist of that. Again, quite a few of these points are recaps of what you've heard from Felix and John. Best of breed expectation, the various components. People have always purchased appliances that do the things, their favorite vision switcher, their favorite replay server, etc. They need to be able to do that moving forward so the industry can innovate and create new tools. Also, okay, so I actually said 2015, Felix did 2014, I think, but I try to anonymize it without giving out the names of the two organizations involved there. But basically, AIMS was formed specifically to encourage the industry to unite behind one approach. And that's where I think the key message of today is that's what we feel we need to do with compute media interfacing at this moment. Again, Felix has unpacked the differences between some of these proprietary or de facto standards that have come to exist. Some of these are kind of platform and infrastructural things. Some of them are completely closed ecosystems. Some of them are fully open, like SRT. Others much more constraining, like NDI, in terms of the way they do it. But there are a lot of things out there in the world, and it's interesting to see the reason some of these have taken footprint is because they've actually kind of worked out of the tin. So SRT, there's been a great interoperability, and although I feel REST is actually a far superior toolkit of ARQ technology, SRT is one, although Mr. Edwards did say earlier today, one thing that we did manage to do with starting RIST was to maybe accelerate the open sourcing of SRT. So at least we helped the industry do that. NDI, interestingly, is very constraining because it's a black box that you have to put in your design that you license, so it doesn't give you the ability to innovate and do alternative implementations of that. And in the middle at the bottom, obviously, is AWS's CDI. And again, for those of you that aren't familiar with the journey, basically AWS have been present on the GCCG work, and we effectively took the kernel of what AWS put on GitHub as CDI to actually start the journey that we're actually on with this. By the way, I'd like to apologize for both the latency and the compression of the audio system. It seems very, very strange. There's a slight delay. It's definitely not an analog connection. There's probably 100 milliseconds. It feels quite strange when you're talking, and it's very, very heavily pumping. Anyway, John's talked to you a lot about the GCCG work. So a couple of things just want to say on the right-hand side, further to what John's saying. First of all, it's now being prototyped. I think 2 organizations that I'm aware of, including ours, have done a GCCG prototyping of the actual API. So we're literally on the cusp of being able to do interop of that media handoff. Now, that's not to say it can't further evolve. Looking at the flexibility Felix is looking for, I think that's good. And I think the example of the changes hopefully we're about to make on moving from P groups to 16-bit planar for the video as the default behavior, etc., shows that we're actually evolving. And I think that's a statement because it's probably 2.5 years since we kicked off the GCCG work. And in that time, compute and the use of compute and the proving of the speed both of interfacing and compute has actually shown that actually 16-bit linears is the thing. So just to expand on that for 1 second, coming out of 2110 as we go into the compute interface with effectively unpacking the P groups, stay linear within the compute cycle, within the chain of concatenated compute functions. And then when we need to hit back into a 2110, we can actually reinitiate the P groups. But it's all about making it compute native, as efficient as possible for the compute to actually work. I'm not going to talk to you about the right-hand side at all because Felix has already waxed lyrical about that. Just a couple of observations on the BBC. So the TAMs that BBC have been talking about, this came off the back of some work they've been doing in wildlife production for the last 4 or 5 years, really. And what they were looking to do, and this is kind of that halfway house between post-production and non-linear editing and live production workflows. But this moving from a signal-centric connection to a storage-centric connection in the way you're thinking about things. And we did indeed discuss some of this in the GCCG work about 18 months ago. There's a bit of a difference there, and the main difference is latency. That's really the only penalty. So as you move your chunk size to be smaller and smaller and smaller, the latency becomes less and less and less. but obviously there are other inefficiencies that come in there. So there's some trade-offs there. The BBC present this as being right on the edge of signal-centric, so very, very close to signal-centric. And if you go down to frames worth of buffering rather than having long gops of data with a second's worth of data or whatever, then actually the latency can be pretty low. But it's a different way of looking at things, and I think even if we stick with an API such as the GCCG-like one we've defined, I think actually shimming in and out of a storage-centric model is going to be important. So we actually have that storage-centric approach as an option. I think it's definitely something there. The other key thing about TAMS is this whole reference plane. So you're actually referencing the media. A lot of the hard work you're doing is not with the media itself, but with the references to the media, which makes it a really, really straightforward thing to do. Okay, I'm going to jump through a couple of slides here because I think most of these have been talked about. I showed this slide last time in VidTrans when we did a remote demo of some components, and this is some work that we've been working with with Frame, another organisation in the UK, at prototyping some elements on, which has worked very well. The control plane, it's interesting. NMOS does seem to be something that should be extensible to fully use. Different people are actually doing different ways of messaging and control within their infrastructure, but I do think we need to hone in the control plane in getting something that's open. And I think a variant of NMOS, and there is some deltas from where we are now with NMOS to where we need to be. Just coming into close now, and then we're gonna jump to the next piece. So these are some of the key things I think it's important. Most of them are very obvious: compute native, asynchronous in behavior. It needs to be fully scalable in the way it's architectured. Security is important. We've already covered that. The control and the orchestration are both very important. Host platform agnostic. One of the challenges that we do have in the industry is making sure that absolutely the layer that we're talking about can be implemented on any compute platform that we want is needed to. But that abstraction, I think, again, is a key requirement that's come to that there. Standard media formats, I think we've almost reached unanimity in the last couple of weeks on this in discussions. So I think we're there. Fully time aware. Now, I can talk about time, as most of you know, for a long time. But the main thing about time, fully time aware, the most important thing is the timestamping and the propagation in a compute world of the origination timestamps, or at least the ingress timestamps, whether it's origination or ingress. There has to be a moment in time where all of the ISO feeds are timestamped, and that timing information has to be propagated through the ecosystem. And again, that's something I think Felix has brought out, and that's something that we've talked about and are honouring in the work that we've done in GCCG. Low latency enough, and I think that's an interesting thing, and that's where I think this signal-centric versus storage-centric model comes in. What is the barrier there? Where do we need to be ultra-low latency, and where could we actually deploy a storage-centric model for a fair bit of what we're doing? That's a debate to be had. And resilience, that's another thing that is a given as a requirement for broadcast, which we need to make sure is fully architected into what we do. So just coming back as I end, the Alliance of the Willing, call to arms, aims 2024, whatever we're going to call it. But I do think, and I've had conversations with Mr. Briscoe and other people in the last few weeks in other entities as well, saying we do need to get the willing together to actually say, let's make this happen and get the collective will. And I think we've got enough users and enough vendors that have the will to actually do something that's actually going to be meet the requirements here. So my obligatory last slide, an invitation for a cup of tea. So don't forget, if you're in the UK or even NAB New York, I'll see if I can find a decent purveyor of tea at the Jared Centre for Wednesday and Thursday. Come and find me. Thank you very much.